Like I said, if you guys are comfortable with showing your screen sometime, that would also be great. So going back to our Google Doc, let me just share this link again. So just so we have some like, sharing some. So I want you guys to, sorry. I want you guys to go to the Google Doc, and I want you guys to answer this question about, I hope you guys have learned something yesterday, right? So like type something that you have learned, a function or comment that you have learned yesterday, and what it actually does, just as an icebreaker, so I can see what has been memorized into your head. So I'm gonna type here, Maria Isabel. I don't know. I'm gonna say install package. It is a function used to install packages in R. So like try to think about something from your memory, but also if you can't remember anything, if you have a bad memory like I have, then just look through our R script. So a lot of people are saying different things. So Robert says filter to pick up of specific rows, and that's correct with the package dplyr. Amelie using the help function to look up what a specific library, like what a specific function does, and what arguments we would want to have for that specific function. Daniel is saying call names, and then call names actually, yeah, so it lists all the column names of a given data frame, for instance. So Daniel has said a lot of stuff. Alex said install package, library, read table. Gil said filter, which is to select specific role items from a data frame. Maya said get WD, which is the function used to find out what working directory you are at that point in your RStudio. Kanika said read table and read CSV with arguments to view data, and actually not only to view data, but also to import the data that you are interested in being working with. Ricardo also said about the $, which is then used if you have a data frame, you can just do the $, next to the name of the data frame to select a specific column of your data frame. Sara talked about reads.csv, which reads CSV file and creates a data frame. And like we talked about, when we are doing this read CSV, we expect that, maybe I can make a comment. We expect that the default separator is default sep is equals to, let's see, people, no. So it's it equals to comma, right? Read CSV to define a variable, I would say more to like import a variable, import import a file. Oops. Rolf said, filter in subset. I can organize any data and get only the information I want with filter. Jesenia said that learned how to import data from computer or from an online database. Michael talked about the read table and about how we can specify if a column has, if a CSV file has a header or not, right? So true, if it has a header, and then we're going to have the column names in that specific header, and false if it doesn't have a header. Do you remember what the column names are going to be looking like? So if false, then the default is column names to be V1, V2, V3, and so on, right? And then install package, library, and then Jenny said about read CSV, and Joe said about S, blah, blah, blah. Actually, for classifying data, but more specifically, I would say for changing the type, the class of a given vector or object. Cool. So I'm happy to see that you guys have learned something from this first workshop, first day of the workshop. And today, what we're going to be doing actually is a bit more of this data wrangling and like data manipulation with dplyr. I saw that a lot of you guys were excited about the function filter and function select, and we are going to be using that more today. But we also going to be doing more of plot and data visualization. I think I think one of my favorite things about R is that it's very easy to plot in R. So I hope you guys learned something today that's going to be meaningful for your research at UCLA and beyond. Okay, so let me just check with you guys if, raise your hand if you have your RStudio set, and if you have your working directory as your, as the one that it is part of this part 1 R project. So 9 people have raised their hands, 12. 13. 14. And I also want you guys to be in this place, in this specific, more or less line 491. I guess it could be a bit different numbering depending on what you have been typing on your R script. I want you guys to go to this specific place. So I just asked people to raise their hands if they have RStudio open, and if they have set their directory to be this project to be set as our working project, the R.R project working directory. So I have 16 people. What is happening with the 17? Just so we are all, we have to set Sion, can you answer the question there?
Okay.
Okay, so I'm just gonna go briefly through this test what you have learned. Sorry. Okay. So for our example research question, we want to find a way to visualize the number of vaccinations density of COVID-19 for every state in the US. We need to import some COVID-19 vaccination data for the analysis, and we have done that before, right? So how many observations and variables are there in the full county vax data? Actually, here we don't want to for every state in the US. We are actually going to just be focusing on California, like we have been doing so far. So how do I find out what to know what a number of observations and variables that we have in this specific object county vax data CA? So there are two ways. One way is just doing what? It's just doing view. Michael say we can just use view. So county vax data and view with, yeah. So then we know here that we have those 25,810 rows and 21 columns. So these are also called observations and then variables. Another way, Joe said, Maya said, just click and then look at that. But then another way that is more kind of nerdy, I guess, that Joey said, he said, actually it's not row names, but actually this is in row. So you do county vax data. So these are, so any rows, number of observations, and then for columns, how do we do it? To find out number of columns, yeah, in column county vax data. Okay, number of columns or variables, also called variables. But here you can also see that, right? And you're gonna find it. So what variables do you see in the COVID vaccination date? So this is what Joe was talking about, or kind of. So in order to describe the name of the variables that are found in the header, then you can just use call names, county vax data, CEA, and this is gonna give you a list of describing all the column names of that given data frame. And then what do each of these column names mean? So I don't know if you guys remember, but Ibrahim has gotten this data frame from this GitHub repository called like Tuesday dataset or something. And if we go there in this specific link that I'm gonna be dropping to everyone, then you can find exactly the description of each column for of this data frame that we are using. I mean, because the name are so well described, it's kind of very intuitive to know what each column stands for, right? Like, so doses administered are the total number of doses given on S of this specific date. So date is the date for which data were reported in this specific format. County, the name of the county. FIPS are the FIPS code given to the county by the federal government. I have no idea what that means. So, but could be used to merge with other data sources. population, the number of people who live in the county. And as we remember, what is the county that has the highest, the largest population size? And how can I do that? How can I find out? Instead of looking at the table, how can I find out? What is the county with the largest pop? There is one function that we could use for that. Yeah, Marco was right. So we can do like this: max, county, vax, data, and then we select population, and then we're gonna, oops, sorry. Actually, this is max, this is the population, but you guys have not learned this, but like which, we could use which to describe in county pop data CEA. I think we could do where maybe or which max, yeah. Oops. So it's saying 19. Is that the 19 column? Yeah, and then we can just, I mean, here I'm doing something that is kind of data frame slicing, but you guys don't necessarily need to. No, row. Yeah, so this which max is actually giving us, for that given column, what is the row that corresponds to the maximum, the highest number of population. And here I'm slicing our data frame by that specific row. So I'm saying like, I want a row 19, and that's what is dropping to me. And then if you want to be even more precise, you can say county, and then you're going to be selecting the county that you are looking at. Okay, so our next step is to merge the two tables together that we have been looking at, the county pop and the county vax data California. So to do that, we will need to tell R where the two different data sets they align. So we need to find out from these two different data sets, what is the column that correspond, like that is the same in the different data sets. How do we do that? So how do we find out what is the column that, there are multiple ways, and I know you guys, some people are going to be like typing, some people are just going to be looking at the data. So I want to find out which way you guys want to do. And I'm going to do the way you guys say. So the two data frames that I'm talking about is the county data facts and the county pop. So we need to find out the two columns that are corresponding in the different data frames. I'm waiting for some advice. Maybe we could, okay, maybe we could look at the column names. So how do I do column names? How do I find out the column names of each. Yes, then you say column names. Okay. So we know that county vax data is a bit larger, right? It has like 21 variables, 19, 20, 21. And then we do also do the column names for vax pop, but thanks God, vax county pop is much more smaller. And it seems here that county, we have county there and county there. So one way to merge those two different data frames is through these columns that they overlap, which is the county column. So for us to do this merging, we are going to be using dplyr. And then if you guys, I'm sure, like if you guys have modified your data, I'm just rereading here again. We are just rereading here again. And we are in a bit gonna merge those two different data frames and create a new data frame. But before we do that, I just wanna make a quick fix for a specific column of this county vax data, California. I don't know if you guys remember, but yesterday we had this column, which was the population column. But when we were looking at, so you can run this one, but then we were looking at the class of that column. We are talking about the county pop. When we were looking at the class of county pop population, in that specific column, we had strings instead of numbers. And we actually, what we really wanna have is numbers, right? Because population size is a number. So one way to fix that is to use this function called gsub. And basically what we are doing here, we are replacing every single instance of a comma to nothing. So this is like nothing. It's interpreted as nothing in that specific column called county pop population column. So I'm gonna drop this into the chat for everyone. I'm also gonna put that into our Google Docs here. How to change the column population in the data frame or global variable county pop. So this is the trick. And now if we look at that, we're gonna see, oops, I haven't tried. We're gonna see that now we have this population column is a numeric, and we can use that and behave, that's gonna behave as a numeric column and not character. Raise your hand if you manage to fix that, make that fix. Also, guys, feel free to always like speak up, talk to me, talk to Sion, ask questions. The more you ask, the faster we are gonna go through the workshop. Yeah, so basically, this is like gsub is trying to say like substitute or replace, right, every single instance in that specific vector, every single instance in that specific, now we don't have it, right, but replace every single comma to nothing. So take get rid of the commas, basically. Are we counting the hands now, right? How do we do that? 4, 5. Okay. So don't do that. Don't do this unless you. If you read again, then put this one here below here. So you can read it again, and then we're gonna see that it is like as a string, but then you're gonna replace that, and then things are gonna work out fine. Okay. I'm just waiting for more people to raise their hands just so we are all at the same page. Yeah, please give me some feedback, like just raising your hand is good because then I can move on. So I have 15 people, 16. So here we decided to okay, 16 people have raised their hands. I'm gonna move on. For those that have not raised their hands, is there anything that
it's showing me character instead of numeric?
it's showing you? Maybe because who said that? I don't know who talked.
Yeah, it's me.
Who? 18. Okay, more people. So maybe because you read the sorry, you read it again. Maybe that is the problem. But then try to, like, you read the object again and then it messed it up again. So try to, once you do the read table, blah, blah, blah here, try to change try to type this specific argument again to see if you can change to numeric.
So you mean do them separately?
Like do it again, because
Oh.
we are supposed to, once you do this, you're supposed to get it fixed.
Right, I'll try this one. Yeah, I got it fixed.
Perfect. Okay, so we had 17 people raising their hands. I'm going to move on. It's not very important for what we have now, but I just wanted you guys to learn how to fix that. So here we want to filter because we are actually not going to be using that specific column population. We are only going to be emphasizing or concentrating the next steps into the population per 10K. So one way to get rid of that specific column population is actually to delete that, to select only county pop, county, and per 10K. So we can get rid of that column. So we just do that. So to refresh your mind, select is to select columns and filter is to filter specific rows. Okay, so now we have county pop and the county vax data, CA, California. And like I said some time ago, there was one specific column that was coincident in the two different data sets, which is the county one. And there are multiple ways one could merge the two different columns, but the one way that we have decided to do is based on this function in dplyr called left join. So because this is a function that you guys have never seen before, let's just understand what left join does. So one way to do that is we go to our help here, and then we say, so okay, what does left join mean? And then we click there, and then we can see that mutating joins add columns from Y to X, matching rows based on the keys. So inner join includes all rows in X and Y. Left join includes all rows in X. So we are saying that we want to, and how is that? So we are saying that we want to include all rows in X, and we want to merge the rows from this data frame in X to the data frame in Y. And we want to say that the columns that match between these two data frames are called county. So, but one thing that is we need to learn to remember is that a county in county pop filter has this uppercase C, while the other one has a lowercase c. So let's see what happens. So what do you think it happened? So someone can describe to me what happened. Correct. So we basically like Michael said, it treats them as two distinct roles. Basically, like if we go to the merged one, what we did actually, we took the county pop data frame and kind of whatever there was that was with Los Angeles there, we would like include. So county pop basically became part of the county vax data California in a way that it didn't change the number of observations for the county vax data California, but included all the information that was present in county pop. Do you guys get it?
So is this matching the county uppercase with the county lowercase? And so it's just keeping one of the columns?
Yes, let's just do the other way around, just to as a test. Instead of doing just so you guys understand. So instead of doing the county pop filter, which is county pop pop with the bigger data frame, let's do the other way around. Let's do like flip the data frames, just so you guys understand what could happen. Actually, nothing changed. So Sarah is saying that she's getting an error that she couldn't find the function left join. The function is part of the dplyr. So you need to load. Do you remember, like when we were in the very beginning of our workshop, when we were doing the library stuff here, you need to do the library of all of these things. So load those packages in order to be able to use the functions. And for this specifically, we would need to load the library dplyr. Try to do that, Sarah, and see if it works. So I think so. This is what it does, right? So it says, like, let's take this county and let's just repeat. Let's kind of like merge everything that is in county pop filter to the county VAX data California without really changing the number of observations in county VAX data California, but including the two informations from county pop filter, which is county and per 10K. And if we look at the merged file here, we can see that per 10K and county. So we have merged county, right? So county uppercase and county small c case is the same. But then we have included this per 10K, which was the different thing, the different column between county pop filter and county VAX data. Okay. So, but there are many other ways many other functions that we could be using in order to merge different data sets. And you guys could later play around with these different functions or commands like right join, full join, and see what those things does to your data frames. But I'm gonna leave this for an exercise. Okay, so
I
this
have a quick question.
Yeah.
So with the test merge, it came up with, so I'm showing basically Alameda County with the original merge, it's LA County. Is there?
Yeah. So the only thing that changes is the name. So we are just changing the name, right? And then
Okay, got it. Yeah.
apparently this per 10K. So the thing that we are using as a default is the small one, but it does the same thing, but it only changes this column name.
Okay, thank you.
But if we do the left join, maybe let's try and see what happens. The right join, sorry, right. In my view, I think it's gonna be a much smaller data frame, but let's see. And it's gonna, yeah, I think it's gonna be like 58 observations, but I'm just guessing right now. It's not. Can you help me explaining this, Si-Young?
So if
I
you,
think the inner join would do what I'm thinking.
yeah, inner join only includes the rows. So what is happening here is for the left join,
Mm-hmm.
we are guaranteed that we have everything on the left data frame, even if the key column that doesn't match on the right data frame. And for the right join, we are guaranteed that the rows in the right data frame exists on the result, even if the key value is not in the left data frame. Inner join requires both each one to have its matching key value on the other data frame.
Mm-hmm.
And full join, we will have all the rows regardless of if we have matching values of the key column or not.
Mm-hmm.
And if you don't have the matching values in the key column, we will get the values of NA for the other data frame values.
Mm-hmm. But because I think here it doesn't matter very much, because we for both things we are only looking at California, right?
Yeah, and
that's
all
why the left join or the right join doesn't really matter, because we are only looking, the two data frames are both from counties that are only included in California, right?
Yeah, and all the counties, and we have the data from all the counties, so so we have matching value on the other data frame for yeah.
So but for instance, if this county vex data was from everything, not from California only, then that would make a difference. Do you guys get it? I hope you get it. Okay. So like, I don't know who asked me yesterday, but like yesterday we learned about select and filter, right? And someone asked, can we just, maybe Ricardo, can we use select and filter in the same command line? And actually we can, but the way we do that is with this command called pipe. I don't know if you guys have heard about this command before, but it's basically to connect strings of commands together. And so instead of like running one command at a time, when you have that pipe associated with your script, then all the commands become connected. So that makes it easier, because then we don't need to have one line of code and then the next line of code and then the next line of code. So that becomes much faster and more readable. And also, I would say also much more organized. So for instance, here, as an example, here we have this new data frame, which is the data frame that we'll be creating after we run this whole thing. So we take our old data frame and then we say, I actually, from this old data frame, I want to select column 1, 2, and 3. And I also want to group my data frame by column 3. And I want to mutate, so transform my data frame, create a new column in which I take column 2 and I multiply by 2. And after this operation, I actually want to filter out every single row in my data frame that is an NA. Of course, this is just an example. So if we run this, and I can run this, it's gonna give us it's gonna fail, right? Because we don't have any object called old data frame here. But just so you guys understand that these multiple commands, they can be run together because of this powerful tool that is this character called pipe. So if we translate this kind of exercise of using pipe to our data frame, we could do the following. For instance, let's take our VAX data merged, and let's just have a look at that again, just so we remember. So remember that we just merged county pop filter with county VAX data California, and now we have 22 different column names. And then one thing that we can do is to use the function mutate. And basically what the function mutate does is it creates a new column into your data frame. And mutates, by mutating, we can say something, okay, I want to create a new column in my data frame by doing a specific operation. In this specific case, what we want to do is to calculate the vaccination density. Someone asked something. Yeah, mutate should be, no, shouldn't be capitalized. So this was wrong here. Should be like lowercase, like we have for all the other things. So what mutating is doing, like the name, like mutating, so transforming, changing, right? Mutating is creating a new column called that we are gonna call VAX density. And VAX density is basically taking the number, the total number divided by the population size, right? And we do that here. So let's just stop here. I'm gonna, for a second, not use the next one, and let's see what happens. One thing that you can do to, okay, let's see if everyone got the, raise your hand if you got the column, if you got a data frame called normalized VAX data, and if you got the column called VAX density. So you can raise your hand if you got the data frame called normalized VAX data, and then if you got the new column called VAX density. And so you guys know, every time that we create a new column, it's going to be placed in the end of our data frame. So the last column of your data frame. So the top right. So stay with me, guys, because I want everybody to be at the same page, because once we do this, we are going to be plotting data from this data frame. So it's very important that everybody is on the same page. So raise your hand if you have the data frame called normalized VAX data. And if you also have a column, a new column called VAX density, which is the fully vaccinated by the population density, the population size. Yeah, so Joe asked, all data frame not found. So this one is just a toy example, like it's not gonna work because we don't have actually. So I'm still waiting for people to raise their hands. So 11 people have raised their hands. On the 14, 15, I'm only gonna continue if more people, yes, 16 up to 20. If we are 20, then we are good. Raise your hand if you got the normalized VAX data, and if you also got the new column VAX density. Yeah, so mutates not only adds a column, but you could do anything with that, like to create a new column. You could also just multiply per 10K by fully vaccinated. You could sum 1 to that. Like you could do many different operations with mutate, you know, and that would create a new column that it's correct. But here you could do anything basically. Okay, so now, so Alexander said that he had to step away for a moment, and he got stuck at the merging step. So let's just go back to the merging step very quickly. The merging step is basically just taking county pop filter, which we are just selecting county and per 10K, right? Okay. So 18 people raised their hands, so I can help you out, or Sion can help you out while we are here. We are going to take a break in 1 second once we do this one here. So now, when you use the pipe, you're saying do the mutate, but also do the next thing, which is like, okay, I filter every single row from that specific column that I just created. So we are only going to accept columns in that specific column, numbers that are above 10. So what do you think is going to happen? So now if we compare our VAX data merged with our normalized VAX data, we can see that the number of rows are different, right? And this is because of this filtering step that we said, okay, filter out every single row, get rid of every single row in that specific column that is below 10, right? Only accepts anything that is above 10. And this is the power of the pipe, because if we didn't have the pipe, then we would need to type many more things in order to get this done. So now, since we just reached 10, I'm gonna give you like 10 minutes break, and we come back after 10 in order to think a little bit more about the pipe and how powerful that is and what different things that we could use with the pipe. and with different functions. So if there is anyone, so you can just, I'm gonna pause.
What's the C again for the merge?
What is what?
Like the letter C before the county on the function.
The
When you're
letter
merging.
C
The left join function.
before the,
There's like,
where?
The left join and then county pop filter, county vax data, and then by equals sign, and then C.
C. Can you print it here on the chat?
It's on the, yeah.
Ah, okay. C is creating this. It's actually creating a vector of these two different strings, county and other county and smaller lowercase c county. So okay, let me just share my screen. So he's asking about what does this C mean? So whenever you want to create a vector, you can actually say vector of numbers. You can actually just use this C to concatenate different vectors. And then if we try to type the class of that vector of numbers, you're gonna see that it is numeric. So it is it's a powerful thing because it could concatenate numbers, but it could also create a vector of letters, right? And we need to remember that letters in R, we need to put them between quotes, otherwise it's not gonna understand. So this would be a class of character, right? So this is what did that C mean? Oops. Means. What did I forgot one. Okay. So now we learned how to mutate. So mutate is producing a new column with whatever operation we want to make for that new column. And then we also learned that pipe can be used like to concatenate different commands in one go, basically. So when performing calculations, NAs can be introduced where calculations fail. It's a good practice to check your data every time you do a calculation. There's a mistake here. And to be sure everything works as expected. So NAs sometimes trip up some comments in R, so it's very important that we get rid of those NAs from our data frame. We can remove rows containing NAs using the filter command. And the way we could do, here we have no NA, right? But the way we could do this is by saying, how do you think that we could do this? So basically what we could do is to say, for that specific operation, give me anything that is different than NA. So this operator here symbolizes that we want something that is different than this specific command, this specific string, for instance. So these are the so-called relational operators. So I guess you guys, when you're doing math, you know that is what those different operators mean. So I'm gonna type here and you guys gonna say what each of those operators stand for. So this one stands for so Amy says means not equal to. What does this one stand for? Greater than. And then what does this one stand for? Less than. And this one, oops, I think we need to do this one. Greater than or or equal to. So we could use all these different operators in order to filter our data frame in the way that we actually want to. So what if instead of if we wanted to, that our plot that we're going to be plotting soon show data from states once they reach a threshold of 50 cases per 10K residents. So how would we write the filter command to remove all VAX density values below 50? So I'm going to give you 2 minutes to do that. And you can cheat. You can have a look at the comment above just so you guys remember how to do that. And whoever wants to paste their results on the chat, I'm gonna be happy to copy and paste into my R script. So the basic idea is that we wanted to filter out anything that is below 50, right? Into that column called VAX density, which is our number of cases divided by 10K. It's not really cases, it's 50 vaccines. So Michael actually is the opposite. Yeah. So instead, and actually you guys, no, because we want everything that is above 50, right? So we can just say filter out anything that is below 50 is the same as saying getting everything that is above 50, right? Yeah, I think the way that is being phrased here is to remove everything that is below 50. Okay, so I agree with you that is above 50, above 50. So Emma asked, why do we also need the above lines of code? Why can't we just run the filter line? Yeah, we could just run the filter line, like we could take our normalized that we used here, right? This one, yeah, I agree with you, Emma, that we could just take this one. And here we are actually overriding it. And then we could just do this. Is that the thing that you did? To be more, oops, to be more precise, I would say that
Sorry, this is a small point, but when you say something is below 50, you mean you include 50 and above. Otherwise, you would just say keep everything or remove everything 50 and below. So I think for like full accuracy, you'd say greater than or equal to.
yeah, I agree with you. But because we might not, I don't know if we had 50, but yeah, I agree with you for the interpretation of the phrasing. And then Michael gave another suggestion, or you could use pipe after NA and add the above 50 condition. Sure. That's the beauty of R and programming in general. You can do so many different ways. There are infinite ways of doing this. Okay, so now let's break down a more sophisticated example just to show you the power of this pipe and the power of R in general. So what we are doing here is to summarize last month, which is not last month, it's like 2 years ago, last month. And what we want to do is to actually just take one specific month, which is that month of September of 2021. And then we want to summarize our data by grouping by specifically by county. So everything that is going to be summarized is going to be grouped by county. And then the way that you want to summarize your data is by making some statistics by county. And here we have done like 4 different statistics. So here we are creating the mean number of new doses, the mean number of new Pfizer doses, the mean number of Moderna doses, and the mean of Johnson & Johnson doses. So when we are grouping by county, what we expect is that the size of the data frame is only going to be like this, the number of rows of that this new summarized data frame is only going to be reached the length of the county data. So we are only going to have a very small data frame because we are shrinking it when we are doing this grouping by using this grouping by future. So let's just run this through just so you guys understand what is going on. Sometimes it's easier to see, to have a look at the data before you guys understand what's going on. So like I said, because we have 58 counties in California, so the maximum length or the maximum number of rows of this data frame is going to be the length of counties. So we have 58. And then if we look at that, now we have summarized our data frame with those new different columns that we have just created. So we have the mean number of doses by county, so grouped by county, number of Pfizer's grouped by county, number of Moderna doses or mean number of Moderna doses by county, and mean number of Johnson & Johnson doses by county. Raise your hand if you have managed to create that data frame called that object called last month summarized. And so I wanted you guys to go with me through these different types, and I'm gonna like write comments, and if you guys feel like writing the comments, we are gonna do that together. So filter is looking at the, so keeping only rows that from column date that matches with this specific string, right? Or sorry, that is above this specific string. Above this day or date. And then grouping data frame by county. So maximum number of rows or observations is number of counties, right? And then creating new columns summarizing the data. So taking the mean of new Pfizer doses and so on. So, I mean, if we wanted, so people are asking here. Yeah, so this specific year MD function comes from that Lubri, how do you call it? Lubri package, Lubri date package. And I believe, Gil, that we could use month, year, day, month, year, if that was the case. And then Michael asked, but we can have a look at that if it's possible. Let's see if there is anything called month, day, year. There is. Yeah, so that's correct. So it's intuitive, like you guys were thinking. I was going to ask in our only reach value, no. So we got that fixed. What is the difference between mutate and summarize? So here we use summarize when we are using the command group by, right? While mutate, you preserve the number of rows. Summarize is gonna be connected to the common group by. Okay, so now that we have done all of this data broadcasting, like matching, merging, filtering, summarizing, now we can actually plot our data. And one of the most powerful packages, I think CEO would agree with me, in R is this package or this library called Ggplot. And Ggplot is basically a package that is used to create plots. And the reason why it's so popular is because it's very versatile. So the idea is that in Ggplot, you can build basically every graph that you have in your mind with the same components. So Ggplot is formed by 3 different components. The first one is the data set, and the data sets are the things that we are looking at right now. So, right, vaccine AZ, vaccine NY, or county pop. So everything that it has somewhat a data frame structure. And then it needs a coordinate system. So whenever we are creating a plot, we actually need X and Y for a scatter plot, right? We need X and Y, which is a coordinate system. So you need to inform the Ggplot too that what specifically coordinates that you wanna give. And you also need a geometry. So basically, how is your plot gonna look like? Do you want a box plot? Do you want a scatter plot? Do you want a violin plot? What is the format? What is the shape of your plot? So Ggplot then is able to create a diverse set of plots using these 3 different components. So the data set, the coordinate system, and the geoms. And if you want to like understand very extensively what are the possible functions that Ggplot has, we can go to our cheat sheets. But for now, let's just keep it simple, and then later you guys can explore that. So first, let's pull some data from our early steps. And so what we want to do here, we want to filter our counties with more than 1 million residents, right? Because we are talking about 10K, we actually can filter by 100, right? So 10K multiplied by 100 is a million. And then we want to make a plot that has a structure that is aligned. So we are going to be plotting a line using Ggplot. And that what we want to plot in this specific line plot, we want to plot the total number of positive cases beginning on the first day of the recorded COVID vaccinations for those counties. Actually, it's not the total number of positive cases, it's just the number of vaccinated people. This is not right. So we are going to be using that data frame that we just used, normalized vax data, and we are going to select specific columns that are going to be used for this plot. So let's just filter or select the specific columns using the function select, because this makes it easier. Now we have only just a few columns, and before we had like 20 something, right? So and like I said, we want to only show, because we don't want the 58 counties to be plotted. So let's just like put a very high number. Let's just filter out every single county that is below 1 million population. So doing that, we could just, to do that, we could just use the column, like you remember using the pie, and then say anything that is below 10, below 100, I ignore. So we filter out all the counties that are smaller than 1 million. Tell me what is the size of the number of observations that you have got. So Ricardo said 2,483. Yeah, so that's what I got as well. And if we want to check in the command line, we can say vaccination rate, and that's going to give me the number of observations, and that is the 2,483. So if you want to look at that, we can see that we only have counties that are above 100, right? So this one almost didn't pass our filtering step. Contra Costa, I have no idea where that is located. Okay, so now we have like a much smaller data frame that could be used to plot. And like I said, we want to understand, we want to make a line plot, right? And we basically want to plot the total number of fully vaccinated individuals, and we want to separate those by the counties. I'm gonna plot, and then we're gonna go through this command very slowly, so you guys understand what is going on. Oops. Okay, so this is the total. So the total number of fully vaccinated, and then by date, right? From January to October. And then the colors here corresponds to the counties, right? And those counties, all of them have a population size above 1 million. Okay, so this is the command line to plot a given plot with Ggplot. Now I'm gonna break it through with you guys. So, like I said, we need a data frame. We need a coordinate system. And then what else do we need? We need the geometry, right? So here, the data frame corresponds to the vaccination rate. So it always comes as the first name you will be including. So this is the data frame. And then the coordinate system here is specified by this function called AES. and that AS corresponds to aesthetics. And if we go in Ggplot, we can get some help there, and they're going to tell us what aesthetics mean. Oops. It doesn't say. So it says mapping, default list to aesthetics mapping to use for plot. If not specified, must be supplied in each layer added to the plot. So the aesthetics normally corresponds to an X coordinate, so everything that is in the X axis, and the Y coordinate, everything that is in the Y axis, right? And then sometimes we also gonna have within the aesthetics, things that could be useful for differentiated the plot. In this case, we could be using the function color here. So, okay, so we are saying that we wanna, in the X-axis, that we wanna display dates as year, month, and day. In the Y-axis, we want that column called fully vaccinated. And we also wanna to color the lines that are gonna be produced in this data set, color them by county. And then let's just, when we are using the sign plus here, we are saying, okay, I want this, but I also want this. The sign plus here, it works very similar to the sign pipe that we were using in with dplyr. And then, so like I said, now we have the coordinate system. So now we want to know what exactly, what is the type of graph that we want to create. In this case, we want to create a graph that is that follows this geometry smooth. And this is basically gonna take all our data points and fit a linear model into our data points. And then instead of putting like the observations, like every single data point, we are actually fitting a model that is gonna produce a line instead of all the data points. Oops. So Maya is asking me, what does geom smooth mean? So let's just, like I said, we could create a plot only with data points, right? With the dots, a plot with the dots. But what the geom smooth is doing is taking those dots and actually feeding a linear model into your dots. And instead of just including those dots, they actually feed a linear model into the data. But let's just see how, if you don't understand, we can also go to the help and see what it's saying. There are many ways that you could like fit your points, right? Each single point. And one way to do that is by doing this, using the using different models, right? When you're smoothing your data, basically, when you're transforming your data points into lines, you could do that in many different ways. Like I said, you could use a method called linear model, or you could use this GLM, which stands for, I don't remember. Do you remember, Cyril?
Generalized linear model.
Say again?
Generalized linear model.
generalized linear model, or you could also use this function losses, which is least, I can't remember. So in that case, what we are doing here, we are telling R to say, to use the method auto, and I guess, but we could also say fit a linear model into our data points. So the line is going to be produced by this method called linear model. Let's see what happens. So it is the geometry smooth is using this formula y given x. Do you guys see that basically it's trying to actually just fit an exact linear model? And the auto is basically using the loss method in order to fit y given x. So Sion said that the GAM is generalized active model and loss is locally estimated scatterplot moving. Do you guys see the difference between the linear model and the model and the loss one? And another thing that we are doing here, we are modifying the labels in the two different data frames in the plot. So let's just not run this and see what happens. So, oops, I need to run and then I need to plot again. Emma, I made linear by changing the method that I'm using in the smooth. So then I say LM, then it became linear. So another thing that I want you guys to understand is that when we are using the function Ggplot from this package called Ggplot2, we are creating lists of lists. It's an object that corresponds to lists of lists. And it has all the different information necessary for us to create that plot that is showing in our screen. Okay, so Maya asked, what would the command be if you just wanted data points, no lines? So one way to do that is to change the geometry of your plot. So instead of geom smooth, you could do geom points. Point instead of points. So you see, it's very dense because we have one observation for each day. So basically, it is almost like a linear thing, right? You can see here that we have a point for every single, but I think if you, you see, now you see the many points. So basically what Geom Smooth is doing is trying to make these many points, like trying to fit a model that's smooth that many points. So just to recap, we have this function called Ggplot, and it requires three different things. It requires a data frame. And in this case, we have a vaccination rate here, so a data object. It requires a coordinate system. In this case, it is defined by this function, this command here. called AES, which stands for aesthetics. Within that aesthetics, I can define many different things. If I want to make an XY plot, I need to define the X coordinate, the Y coordinate. And then if I want to even further discriminate my data by a given column in my data frame, I can use the function color, which is going to color your data, your plot in a specific way. Here we are asking it to be called by county. So it's basically a group by in Ggplot, and then we not only data frame and coordinate system, then we need to tell our what is going to be the shape of the object. And to make the shape, we use the function geom something, geom underline point, geom underline line, smooth, geom underline box plot. So that is how we make a plot. Whenever we want to add a layer, an extra level, an extra layer into your plot, you can use the sign plus here. In this case, what we are doing here, we are changing the label name. You see here that when we don't use this labs, the label name is going to be exactly the same name as you have given here in your AS coordinate system. Sorry, fully vaccinated and YMD date. You see here that is the same, right? But if you want to change that, you can add an extra layer with the function labs, and then you can write exactly how you want your labels, X and Y labels, to be looking like. Okay, so this is what we were talking about. So this YMD, like we have discussed before, comes from this package Lubricate, which is very neat because it separates dates in this very nice way, right? Like here, months are very nicely separated. And if we didn't have that, our dates wouldn't be looking as nice. And you guys can try it after our workshop to see what happens after this. And like I said, we need the data frame, we need a coordinate system, and then we need geometry. We need to tell the shape of our plot. Okay, so now I'm gonna let you guys tell me what I should type in the following command in order to create a new plot. So I want to check if you guys have a good memory. So tell me what exactly I should type in the places where there are x-axis in order to get a specific plot. So I want to plot full vaccinations per 10K residents. And I want to plot in the x-axis the date, and in the y-axis these full vaccinations per 10K residents. So what should I be putting here? Yeah, so I should put date. And what should I be putting here? Yes. So Michael said that jumps move requires a method, and we are saying when we say out is basically telling the software to the program to do what they think is best. And then now, if we plot this, we can see that. So the method, the jumps decided to use the loss method, given the formal y given x. And now do you see that before we are looking at the total number of vaccinations. So we were not taking into account the fact that different populations have different counties have different population sizes, right? But when we are doing here full vaccinations per 10K residents, we are taking a normalized data, right? So we are taking the density. So we are normalized the data by the sample size. And here it becomes more clear the trend of vaccination rate through time. So raise your hand if you have gotten so far and if you understood the difference between the first plot and the second plot. And just so you guys know, after this, we're gonna have a break because I know that it's a lot to take, a lot of information. So 7 people have raised their hands, so they managed to get the first plot and also the second plot, in which we are not plotting the total number of vaccines anymore, we are plotting the vaccination density, in which we take into account the population size per county. 11 people, that's great. $13. Great to see that a lot of people have managed to get so far. So now it's 11. Let's say that we are gonna be back at 10 past 11, because just take a, like, go drink some water, take some, I don't know, stretch your legs, and we are gonna come back in a second. 10 past 11. And here, we are basically gonna be just exploring a little bit more on the functionalities of Ggplot, and like just to like reemphasize what are the specific objects that are necessary to in order to create a plot. So this, we have done this before, right? When we filtered out our vaccination rate by that date. But let's just do this just so we have this data frame created. Sorry, this is gonna give us even smaller number of observations, because we are asking here to only get dates that are above or equals to that specific date. So what does exactly this function do? Do you guys remember? Let's just try to do that without the function to see what happens. I think it's gonna give us an error. It didn't actually. But this is basically to specify that our dates are given by year, month, and day, and not in a different way, right? And then in that way, you can really emphasize how the date is described. Oops, oh, sorry. Okay, sorry guys, I skipped one. I skipped one. Okay, we were here. So we are around line 700. And we are here. Oh no, it's not 700. Here. Okay, so we are around here. Vax density plot. This is our vaccination by density in large counties, and large counties meaning counties with population above 1 million people. And we are plotting the density, so the number of vaccinations by 10K residents. And only 1, 2, 3, 4, 5, 6, 7, 8, 9 counties in California have a population size above 1 million, including Los Angeles. But you remember that Los Angeles was on the top here, but with this normalization, we can see that actually the best county is Santa Clara in terms of vaccination rate. So one other way to set, like I said before, this way we are plotting every single line in every single line in the same plot, right? So all the counties are represented in one plot. But there is a way to actually separate each county into a different one singular plot. So each county would have its own plot, and in this way we have to do that. We have the common facet wrap. So facet wrap basically is gonna, like I said, split your plots. So multiply your number of plots by a given observation, in this case county. So if we want to make the same plot, but by like splitting it up, what should we do here? So we want the vax density here. And then we also want to color it by county still. So, and then we also want to be like this line, smooth line. And then we want to split each of those lines by the county. So each county would have its own plot. So try to do that and see what happens. It's taking forever. Sorry. Did anybody get it? Their bots? Is it also taking forever for you? Ooh, that's not good. No. I don't know why. Okay, so I don't know why I decided to complain. So this is life. No. Sorry guys about this. So yeah, so like if someone wants to share the screen, their screen. So basically what it does, it split the different plots into okay, so I will need to run some of this again. Yeah, because my art just stopped it. I'm sorry about this. Oops. Okay, I will need to run very quickly again, just so we guys, we have it all. Okay, so starting here.
Thank you, Ricardo. He added the screenshot to the Google Doc.
Say again? You just said that.
Yeah, Ricardo says that he added the plot to the Google Doc we are using, so you can see the plot there.
Perfect. Yeah, okay. So let me just load this stuff here so I have everything. Sorry. And then I'm gonna run very quickly through the second session.
Okay, let me share the screen while you are doing this.
Okay.
So on the bottom right is the plot we wanted for vex density plot facets. So it basically splits the plot for each of the county. Maria, do you want me to continue the next lines or?
Just for a
Maybe.
second, because yeah, it's taking a little bit. Sorry.
Okay.
Actually, I got there.
Okay.
I'm not gonna try to run the facet one because I'm afraid it's gonna. Okay. Yeah, so we get this last month vaccination, and okay, so then we got the vax density plot facets, and we are just splitting it in by county. And sometimes that is useful when you want to separate the data depending on specific variable, right? So there are plenty of things out there, plenty of formats that we could be plotting our data with. And the next couple of times, we're going to be learning how to plot, make a violin plot. So for that, we are going to be actually only using a smaller size. So of a data frame. So we are basically filtering out anything in that data frame that is older than this specific date. And that gives us around 234 observations. And we do that by using this year, month, date function, which is a function that is used to specify how the date is organized. So, like I said, reinforcing here, Ggplot needs a data frame, aesthetics, and a geometry, right? In order to create a violin plot, what we do is we use this function called geom_violin. And then what we could also do is not only like creating this violin plot, but we could also, on top of that, include the data points that are used for this violin plot. So here we are going to be using the county as our X coordinate, new doses administrated as our Y coordinate. And here, note that instead of color, we have the function or the variable called fill, because we are now dealing with a shape, right? A violin is a shape, so we are not dealing with a line. So whenever you need to deal with the shape of something, you use fill. If you are just dealing with like the surrounding of a given geometry, then you use the color. So if you just this is a typo here. If you try to plot this, you're gonna see that, like I said, we separated our data set by in the x-axis we have the counties, and the y-axis we have number of new doses administrated. And instead of using, so we are filling up the violin plot with counties, so county is the color, and we also have the dot plots here, which are referent to this coordinate y, and also the size is specified as 0.5. We wanted that to be called with the color black, and we wanted that to be placed in the center of our our violin plot. And then here is, we are telling Ggplot that we want to use a specific palette of colors. And this palette of colors is that we have specified is the blues one. And we have decided to change the labels of our plot by including a title, doses administered in large counties, and including also a different Y label. Instead of new underline dose underline administrated, we made it like nicely without the underline underscore. So, any questions so far? So Ralph asked, how did you fix the not found again? What is not found, Ralph? Ah, yeah, sorry, yeah, because there was a typo. It was like up with uppercase A. Okay, so this so it's a bit ugly that we have these like overlapping axes here. And you could change them in many ways. One solution is just to get rid of those labels. And to do so, what we can do here is to use this function called axis.axis equals to element underline blank. And that is basically, if we run this again, we are basically gonna get rid of the X labels. But just so you guys understand what is going on, I want you to help me to fill up this. We basically want to make the same plot, but I want you guys to help me fill up this without you guys looking at the scripts above. So what should I write here? So we want a new doses administrated. And like someone asked, whenever we have the axis and nothing is specified by default, we know that the first one that is coming is the X coordinate, and the second one is the Y coordinate. So what should we, what should we be putting in the Y here? No one is gonna help me out?
New doses administered.
Yeah, but I don't think it's written that way. We can try. Or we could also just make use of our friend Ggplot and go to last vaccinations. And oh, so this new doses administered is written that way. You can just then is that how you say? Are you right? Sometimes I like I know it's not useful to have it, but I like to use the $ here. So to remember how it's written, you can take this off. And then how are we gonna be filling it by? By?
County.
Yeah. And then the method that the way that geom violin scales. So let's see how it scales. There are different ways that it could be doing that. Let's just go to help and find that out. So if area, which is by default, all violins have the same area before trimming the tails. If count, areas are scaled proportionally to the number of observations. If width, all violins have the same maximum width. So I think we can choose, let's just choose area just to change a little bit from the previous plot. And then we are telling that the palette, color palette that we want to be using is the blues one. In a bit, we're going to find out what the different colors are out there. And here we are telling Ggplot that we want to get rid of the text in X. And let's just do that again. Okay, so we got rid of the labels in the axis, right? Now we are saying that they all have the same area, and that became very different, right? Now we don't have this function, this geometry dot plot anymore, so that's why we don't have the dot plots anymore. And we got rid of our X label. So, but let's just keep it as width, because I think that's better. So normally when we are creating a plot, we of course want to understand more than just its distribution, but also its mean and its standard deviation. So how dispersed the plot is, what is the variance of your data points, right? So in that way, we could be using this function here is called stat summary, that is very useful and very powerful, because with only one line of code, you can include mean and standard deviation to your plots. So let's go back again. We have county as our X label. Then we have new, what is that? New doses. Doses administrated. Oops. And then we are saying produce a plot that has a violin shape. Use the palette blues. Take the summary, make a statistical summary with mean and standard deviation. And then instead of deleting the X labels, just turn them around like in vertical. So now we have our labels, X labels flipped around in 90 degrees, right? So that's what is the angle, what the angle is doing here. And we have the mean and standard deviation of each data, for each county by introducing this specific set of command. And yeah, and our palette color palette is blues. And we are filling the colors by county, right? So everything here, the colors are defined by the county. And we are, oh, but we didn't change the new doses administrated. Let's just put next the label for new doses. New doses are the means. Good. Who managed to get all the VAX violin 1, 2, and 3? Raise your hand. I received an error, then HMIS package is required. I tried to install but unable to install. What is the error that you're receiving, Kanika, when you're trying to install HMIS?
Yeah, the error says that HMIS package is required to be installed. So I tried installing it and it didn't get installed.
You're trying to install this one, and how did you try that? And when do you get that error?
When I ran the code for VAX file in 3, only this time.
Weird. Is that because it's part of this
Yeah, I think so.
stat summary one?
Yeah, that mean SDL function calls a function inside HMIS package.
So can they just install it, like install package? Oh, no.
In the long error that I get after trying to install, it says this package is not available for the current version of R that I'm using.
And you had R from before, or is that a new version of R, or you had R for a very long time?
No, this is the latest version for Windows.
I think it has to do with version control, right? Like maybe you're unable because your Windows does not accept that. Like the pack 2 is not available for your version, or our version that you have.
Probably.
Sorry, I don't know. Maybe we can fix that later.
Yeah, or I could later try it on a Mac, then see.
Yeah.
Yeah, okay.
Okay. So we have talked about that, right? Like reflections and connections. So when we look at the Jones move, we look at the usage, right? So we figured out that the linear model fits a linear model. LM fits a linear model to the data. And all the other different ones, they have different ways to fit the data points and to make it smooth, right? And we also learned about this scale parameter, right? Like if you use the area, or if you use width, or if you use what was the next one? So depending on what you have, your violin shape is gonna differ depending on the parameter that you use. And we also were able to add the dot plot before. So this is the last part of this today's workshop. I think that I guess you guys are have received a lot of information, as much as yesterday. So I understand that everybody's very tired by now, but let's just take like these last moments to understand the last bit of this workshop. So we have gotten a taste of what R can do with data visualization, and you could easily see that R can, Ggplot especially, can be very dynamic. Sometimes you can just change the geometry, like box plot or dot plot or jump line or jump point, in order to use the way your plot will be looking like. So another thing that R is used for is to make a statistical analysis. And here we are going to be doing like we just did, right, with this with the violin plot. We just saw that we were able to estimate the mean and the standard deviation for each of the counties, and that is kind of useful as well to understand the spread of our data, and to see, for instance, if the different counties are statistically significant in terms of their mean, right? I don't know how much background you guys have in statistics, but one way to compute statistically differences between data sets and like between distributions, you could use the t-test. So here we are going to be first, like when we see when we visualize here, we can do t-tests, like pairwise t-tests across all the different counties, right? But we first we are going to be comparing the means of new doses administered of Los Angeles compared to the mean of new doses administered in San Diego. And we are going to see if those two different distributions are statistically different. So to do that, we can produce one data set of vaccinations only for the county Los Angeles. So like you guys have learned before, we can filter out rows using the function filter, and then we can say that we only want the county Los Angeles. And then we are also going to produce the San Diego vaccination counts, and by filtering counting by this string called San Diego. And then now here, to see how powerful this is actually, now here we are just computing this statistical test called t-test to compare the distributions among vaccination density in LA and vaccination density in San Diego. So the t-test is using a Welch two-sample t-test. This is a non-parametric test, and you don't need to know exactly what that means, but it doesn't rely on specifically one specific distribution. And it's saying that the alternative hypothesis is that true difference in mean is not equals to 0. So the mean distributions actually, the two distributions actually differs, because we can very easily reject the null hypothesis in which the means are equal to 0. So by this test, we can conclude that Los Angeles and San Diego are qualitatively different. And actually now we can see that they are statistically different based on this t-test. But however, if we look at like San Diego and Orange County here, they seem much more similar, right? Like the mean distribution here compared to San Diego is much more apart than the mean distribution of the Orange County compared to San Diego. They are basically on the same coordinate here in the y-axis. So let's just try to see if those here Orange County and San Diego, they differ statistically in terms of the amount of new doses administered. So we do the same. We have the San Diego. We had already that. We had also Orange Vax. And now we compute again this t-test, which is comparing the mean distribution among the two different counties. Is that true? They are still very significant. They are still very significant, actually. Do you guys get also that?
Yes.
But let's see
We're testing densities here, and the plot there is new doses administered.
sorry.
We are testing vax density here, and on the plot is the new doses administered.
I see. So if we change that for new doses administered, let's try to see what we get. So that wouldn't be a good thing, right? Because that is not normalized by the sample size. So that is the way to do that, actually. And let's just plot the violin plot by density and not by new doses administered, just so you guys see what that looks like. We do have that, right? And this is vaccination density. So then you can see that they are still statistically different, right? Maybe all of them would be statistically different. You see here, whenever the means and the standard deviations do not overlap, this would be vaccination density. Whenever the mean and standard deviations do not overlap, then we would discard them to be the same. You guys get it? So this is the end of the part 1. So I guess you guys have learned a lot of things. So you have learned how to include, import data, you have learned how to manipulate data, and you have learned how to plot data, and also have learned like how to search for help, right? So in the next couple of minutes, if you guys have any questions, I'll be happy to answer your questions. And if you have any questions about the t-test, I'd also be happy to explain a little bit more why we had significant tests. But if you are done, feel free to leave. And then tomorrow we are going to be learning how to handle and use R Markdown in order to compile all these things that we have been doing. We could compile in one document, and that is very powerful because it can help you guys produce reports like nothing, you know. So come tomorrow, and you're gonna be doing a bit more of the exercise in plotting, but also on the learning what R Markdown is. I'm gonna pause now, but so there is no homework for today. I think the only homework would be to download the part 2 from that link that I sent by email. And tomorrow I'm gonna be talking a little bit more about the things that those people that are taking this course for grading, what are the next steps that you guys need to do in order to accomplish that, to get that grade. And then thank you, and sorry about it was a bit messy with the crash of my R, but I guess